Hi, everyone. Thanks for joining me today. My name is Jonathan Ha, and I lead the AI Solutions product management team here at Penguin. Today, we're continuing our discussion in the exciting world of AI, but with a focus on getting the most out of your AI infrastructure. Organizations of all shapes and sizes are in a race to utilize AI for growth and competitive advantage, but most struggle with harnessing the full potential of their AI infrastructure, especially at scale. Let me share a few key data points. In a recent survey, about 1 in 3 IT professionals admitted that a lack of AI infrastructure was their biggest barrier to AI success. Not only are they challenged with deploying AI infrastructure to meet business needs, but even if the hardware infrastructure is there, 83% of organizations admitted that they weren't able to fully utilize their GPU and AI hardware once it was deployed. To make it even more concrete, in a recently published study, one company detailed their experience training a 400 billion parameter AI model using a 16,000 GPU cluster. In a 54-day training period, they experienced some type of failure or unexpected workload interruption every 3 hours. Over half of these failures were related to the GPU, memory, switch, or network cable. All these data points just show how big a challenge it is to get the most out of your AI infrastructure. So let's dig a little deeper. When we talk about maximizing the AI potential of your infrastructure, there are 3 areas we're looking at. First is designing the right architecture optimized for your environment and workload. And we'll go deeper into that in just a few minutes. Second is avoiding false starts. That means making sure we're taking the necessary steps to ensure that our system is delivering the expected performance and optimal ROI right from the start of deployment. We want to make sure that our design doesn't just look good on paper, but is actually tested and validated at a system level before we deploy it. And third, it's effectively operating and managing the AI infrastructure at scale. We want to make sure that it maintains the target uptime, availability, security, and performance we expect. Gaps in these areas can lead to significant delays, increased costs, and missed ROI, negatively impacting the percent of potential of your AI system. Let me explain further. There are some hidden challenges that we see customers hit as they deploy their AI infrastructure into a production environment. The 2 main factors are the number of nodes available and the effectiveness of delivering the full performance of the system capabilities. If you think about it, if you did a perfect job on both these vectors, you would get perfect value from your system. Unfortunately, the reality from our experience is that organizations struggle mightily with this. We hear that organizations are challenged to even get 70% of their nodes available at any given time. And on top of that, they may be dealing with unforeseen bottlenecks in the architecture design and only getting 70% of the expected performance. The impact is that this doesn't mean you're getting 70% of the value of the system. In reality, you're only getting 49%. That's 70% of 70%, which is less than half of the potential value of the investment you've made in your AI system. All that lost value is what we aim to make sure we capture so that you can get the full potential of your AI infrastructure. Now, let's look at a few considerations. Imagine architecting a house without ever knowing how the house will be used and never seeing the lot where the house is going to sit on, and then adjusting the design as you build it. That's the risk of architecting and building AI clusters without fully understanding the target workloads and deployment environment. Suboptimal designs may not scale with your workloads and can often inflate costs, cripple performance, and limit the results and return on your investment. GPU servers are one component, but you'll want to use experienced architects who understand your workloads intimately, whether it's model training, model tuning, or generative inference, you'll want to make sure to use validated system architectures, which include both storage and networking, to design your AI clusters. Unvalidated rack, row, and cluster designs can lead to higher costs and unforeseen performance bottlenecks. For example, networking is a critical ingredient in an AI cluster. With multiple network technologies and topologies available, careful design consideration must go into architecting the front-end storage networks, the back-end or scale-out compute network, and optimizing the cost and performance. Depending on the size and scale of your cluster, even the physical layout of racks, rows, and cabling within the data center can significantly impact cost and performance if not done correctly. Also, with the number of power-hungry GPUs found in an AI cluster, suboptimally designing around the power and thermal constraints of a specific data center can lead to stranded or unutilized power capacity, ultimately limiting the number of GPUs deployed. Designing with validated architectures, which have been proven for performance and availability, and optimizing it for your specific workload and environment gets you started on achieving the maximum potential from your AI system. Once you have your design in place, the goal is to deliver the expected performance and availability right from the start. AI clusters are not built by just bolting piece parts together. Building and integrating AI clusters is like putting a gigantic jigsaw puzzle together, where every single piece is vital to completing the puzzle. With thousands of port connections and many miles of cables to deal with, traditional system integration methods are typically not suitable for the complex components and intricate cabling involved in building AI infrastructure. Working with vendors, partners, and experts who have tuned factory integration methodologies and best practices to build AI racks and clusters will help avoid support or troubleshooting nightmares once deployed. Additionally, spending the time and effort to do pre-deployment functional and performance testing of full racks and mini clusters will ensure performance and ROI targets are achieved at initial deployment. This will hopefully get your AI cluster achieving your performance and availability targets starting on day one. Now that your cluster is up and running, the challenge is to continually operate and manage it that way, at scale. For organizations inexperienced in managing large-scale AI clusters, there's a perception that knowing how to deploy and manage compute clusters or even HPC infrastructures is sufficient. But that simply isn't true. These teams are not AI ready and often don't have the tools or the skill set needed to keep your AI infrastructure running on all cylinders. Even well-resourced organizations struggle with GPU availability in large AI deployments. Keeping these resources at target utilization can be a significant challenge. We typically see customers struggle to keep GPU nodes in the 30 to 80% availability range. That means that organizations are either having to overbuy GPU capacity to get to their target availability or performance, or they're not achieving their desired ROI, ultimately impacting potential revenue streams, margins, or competitive advantage. Although health monitoring and management for CPUs and general purpose compute is quite mature, monitoring the health of AI systems, which include GPUs, high-speed transceivers, optical cables, and possibly liquid-cooled systems, is new and complex. Not only do we need the necessary tools to get the insight to diagnose and troubleshoot issues, but your team, whether internal or a partner, needs to have the expertise and experience to proactively address issues before failures occur in order to keep your AI infrastructure humming. Building successful AI infrastructure goes beyond just the GPU hardware. It requires expertise in AI-specific software and hardware design, meticulous integration, and proactive management. Properly designing, building and deploying, and managing your AI infrastructure will deliver powerful business outcomes. These include reducing the overall risk in delivering your AI infrastructure on time and on budget, accelerating the time to value of your AI infrastructure, whether it's to grow new revenue streams, increase productivity, or lower costs, and maximizing the potential that your system will deliver to the business. Having a trusted partner by your side can be the difference between struggling or thriving in the world of AI. They can help you deploy high-performing infrastructure and manage it efficiently for the long haul. Remember, a strong foundation and team is key to maximizing your AI potential. Okay, well, thanks for listening. And now with that, let's move over to the Q&A portion of this webinar. All right. First question is, when you say at scale, can you quantify that? Sure. Thanks for that question. Running AI workloads on GPUs is totally a different paradigm than with CPUs. And we find that like at scale even starts with 2 GPUs in terms of complexity, but there are definitely tiers of scale. Today, like a single rack typically holds 2 or 4 GPU nodes with 16 to 32 GPUs in the rack. And there are challenges even managing that, but there's sort of a t-shirt size scaling depending on the type and scale of workload, type of network being deployed, and even the type of data center that you're targeting. So at Penguin, our Origin AI solution, which are templatized AI infrastructure offerings, start at 256 GPU clusters for our small size, scales to 1,000 GPUs for a medium size, and 4,000 GPUs for a large size cluster. And for customers deploying very large clusters, our large size offering scales to over 16,000 GPUs. Let me see. Next question. What should we do now to prepare for deploying large-scale AI clusters? That's a great question. So to begin with, to prepare for designing and deploying AI clusters, you should first map out your AI use cases, models, and even data sets, and scope out the scale of the infrastructure that's needed based on things like the model parameters, the number of users you plan to support, and any performance needs. Next, you should evaluate which GPU and network technology capabilities are most important for your workloads. And this could be anything from like raw flops or memory bandwidth or memory capacity, GPU to GPU bandwidth, software stack performance, and so on. Next, you should probably look at the KPIs that are going to be most important for the business, like once you're in production and from an ROI standpoint. So these could be metrics like performance per watt, performance per dollar, the time to train, token throughput, or token latency. And because all these metrics may have impacted your choices in the GPU technology or network topologies, air-cooled versus liquid-cooled solutions, size of the cluster, and other design considerations. And finally, with all those kind of parameters understood, you should start really design with the data center, because the power and cooling capabilities will dictate everything for your AI cluster and potential future expansion. All right. Next question. Do you have any customer examples or stories to share? Sure. We have a couple of good ones. So Penguin, we started deploying and managing large GPU clusters for Meta in 2017, back when they were still called Facebook. And through the years, we collected, analyzed, got insights from all kinds of data points in that cluster. We learned how to correlate multiple events to predict and proactively replace failing components before the nodes went down. We wrote scripts, created automated processes, and even filed a few patents, I believe. And at the end, we helped Meta consistently stay above 95% availability of the GPU nodes in their AI cluster. And also recently, Penguin was selected by Voltage Park, a next-gen cloud company that's focused on machine learning infrastructure, to integrate and ensure production readiness of their 24,000 GPU deployment. Penguin is going to be providing both professional and managed services and software to ensure that they have maximum GPU performance and cluster availability for their customers. So there's a couple examples, and we've got a number more on our website in terms of case studies with customers like Georgia Tech, the U.S. Navy, and so on. All right, one more question. For partnership, whom to contact with Penguin? Great question. If you look on the screen right now, there's a QR code that'll help set up a call with a Penguin architect to get things started. You can also scan the other QR code, which tells you a little bit more about our Origin AI AI infrastructure solution. So with that, I think we've gone through all the Q&A for today. Appreciate all the questions. Thanks for tuning in and participating today. And I hope you have the great rest of your day. Thank you.